Bismillahirrahmanirrahim. Today we are going to solve Cambridge O-Level Chemistry Paper 4 Alternative to Practical. We have the subject code 5070 and the variant for this paper is 42. For the session of May-June 2024, we have total time for this paper is 1 hour. The total marks for this paper is 40. So we're gonna start our question paper from question number 1. Question number 1 is that a student find the amount of iron 2 in a solution by titration. The student uses a volumetric pipette to add 25 centimeter cube of aqueous iron to sulfate to conical flask. Add approximately 20 centimeter cube of dilute sulfuric acid to the flask. Slowly add aqueous potassium magnate to the conical flask until the solution just turns pink. Repeat the titration several times. Figure 1.1 shows the operator student uses to measure the volume of dilute sulfuric acid. Name the operator shown in the figure. You know that the operator shown in the figure is measuring cylinder. So that was a very easy question. Moving to its part 2. Part 2 is that explain why the student does not need to use a volumetric pipette to measure the volume of a dilute sulfuric acid. Because in case of titration, we does not need to be very accurate for the volume of acid. So volume of acid does not need to be precise. This answer is we're gonna write that. Part 3. Describe how the student uses the volumetric pipette to measure 25 centimeter cube of aqueous iron to sulfate safely. You can use a pipette sucker to safely fill up the pipette. So this was an easy question. Name the operators student used to add the aqueous potassium permanganate to the flask. So burette is the name of the operators that we can use. Moving to its C part. C part is that state why the student does not need to add an indicator to this solution. Because color of the solution changes at the completion of the reaction from purple to colorless. So if the solution color of the solution changes to purple to colorless, it is indicating in itself. So we does not need to add any indicator for this for the titration. Part D. Explain how the student know when they have done enough titration. This is the question you should do very carefully. So the reading of our instrument of measuring cylinder was 20 centimeter cube. It should be 10% of 20 centimeter cube. So the 10% of 20 centimeter cube is 0.2 centimeter cube. And you need to take so many readings of titration until the difference between two consecutive readings is 0.2 centimeter cube. So you're gonna write this: if the result of two consecutive readings are within the difference of 0.2 centimeter cube of each other, then it would be enough readings for the titration. How you get the 0.2? I have explained it. You just need to take the 20 centimeter cube, 10% of the 20 centimeter cube, that is exactly equal to 0.2 centimeter cube. Hopefully you get the idea of this question. Moving to question number 2. Question number 2 is that a student investigate the temperature changes when a solid completely dissolves in water. The student measures 25 centimeter cube of distilled water and pours it into a beaker. Uses a thermometer to measure the initial temperature of the water in the beaker. Record this temperature in table 2.1 at the time 0 degrees Celsius. Adds a sample of solid to the beaker and starts stopwatch. Start the mixture and record the temperature and the time interval at 60 degrees 60 second interval for every it means 60 second interval for a total of 300 seconds. Some of the results are shown in the table 2.1. Now, part A is figure 2.1 show the result for 120 and 300 second. So at 120, we can see that the reading is exactly equal to 13.5, and at temperature at 300, the reading is exactly at 15 degrees Celsius. So you're gonna write your answer over here. 120 time and the temperature is 13.5, time is 300 and the temperature is 15 degrees Celsius. Moving to a second part, calculate the maximum temperature change in the investigation. So maximum temperature range you can calculate by subtracting the highest value to the lowest value. Highest value is 19.5 of the temperature and the lowest value is 13. So you're gonna subtract it. 19.5 minus 13, your answer will be equal to 6.5 degrees Celsius. So this is the maximum temperature change. Moving to is third part. Third part is that describe the trends shown in the result in the table 2.1. We can see the trends are initially the temperature from the table where you can see that initially the temperature drop is rapidly from 19.5 to 13, but after that temperature start to increase. For every 60 seconds the temperature tend to increase 0.5 degrees Celsius. So you're gonna write this in your answer space. Initially temperature tend to decrease rapidly and after that it start to increase uniformly. For every 60 seconds 0.5 degrees Celsius is the rise. Next part, suggest the temperature of the mixture if it is the left for 60 minutes. 60 minutes means 60 into 60, it means 3600 seconds. Explain your answer. Temperature after 16 minutes is 19.5 degrees Celsius. Explanation, the solution will return to initial temperature at the room temperature. Okay, I'm going to explain this answer. After 60 minutes, it is enough time for anything to become stable at the room temperature. So temperature, the room temperature at the start of the experiment was 19.5 degrees. So after 60 minutes, the temperature tend to be similar similar to the room temperatures. So that's why I have written 19.5 degree Celsius. Moving to its B part, describe the energy changes when the solid dissolved in water. Explain how the result in table 2.1 support your answer. Okay. Energy is absorbed during the reaction. So we know that when energy is absorbed, it means it is endothermic reaction that has been taken place. So we're gonna write our answer as endothermic reaction is taking place. Explanation is that the temperature of the solution decreases when the solid is dissolved. Moving to part C. Explain why it is important for the student to stir the mixture. It is important to stir the temperature solid because to make temperature even, or you can write that to make sure that all solid completely dissolves. So you're gonna write that to make sure that all solid dissolves, or you can write to make temperature even. Moving to part D. The maximum temperature change calculated is not the true value for this investigation. This may be because the volume of water and the temperature are not measured precisely. Explain how to obtain a more precise temperature measurement. So you can say that you can use a thermometer that is graduated to less than 1 degree Celsius interval. It means that for more accuracy you need to take a scale, or you need to take a thermometer in this case that has the accuracy or value of 1 degree Celsius, less than 1 degree Celsius. So this was an easy part. Moving to part E. Okay, moving to part E. Part E is that the maximum temperature change calculated is less than the true value for this investigation. Suggest a reason for this other than precision of the measurement. Describe an improvement to the method for which the reduces this error. So you're gonna write this answer. The reason is that heat gains from the surrounding, because the maximum temperature is less than the because it gains the heat from the surrounding and you can improve it by taking the beaker as insulated. You can provide insulating sheet before the beaker. You can write the answer insulate the beaker to prevent the flow of the heat or heat flow. So this is the improvement you can take to measure that. Now we will move to the question number 3. Question number 3 is that a student does a series of experiments to investigate the solution R. This is the question, comes from the identification of salts and ice. Okay. Part A. The student leaves a wooden splint with one end dipped into R for 10 minutes. The student then places the damp end of the wooden splint into the flame of a Bunsen burner with the air hole open. The student concludes that R contains sodium ions. State the observation which allow the student to make this conclusion. So you can write that it would have a yellow flame. Part 2. Explain why the air hole on the Bunsen burner must be open when doing this flame test. If it is open, it means that air can enter, and if enough air can enter, the complete combustion would take. So you're gonna write your answer as to ensure that complete combustion of air with blue flame. Moving to part B. Part B has a first part that the student add dilute nitric acid to R. The student observed effervescence of a colorless gas which turns lime water milky. State the conclusion from these observations. This is that carbon dioxide is formed, and because it turns lime water to milky, and you can also write that it contains carbonate ion. That's why the lime water should have carbonate ion. Moving to its second part, the student adds aqueous barium nitrate to some of the mixture from part B1. The student concludes that R contains sulfate ion. State the observation which allow the student to make this observation. If the sulfate ions are formed, you can see from the table, then the white precipitate would be observed. The table is given at the end of this paper. Part 3. The student adds aqueous silver nitrate to some of the mixture from B part 1. The student observe a colorless solution. State a conclusion from this observation. The solution does not contain any halide ion. Halide ions are those that are halogens ion like chloride ion, bromide ion, or iodide ion. So that's why solution does not contain any halide ions. This is the conclusion. Part 4. The student adds aqueous sodium hydroxide to R and warms the mixture. Describe a test and observation to show that R does not contain ammonium ion. The test should be use a red litmus paper, that is damp red. Observation would be litmus paper does not turn blue. Solution R is made from the mixture of two different ionic compounds. It's like sodium ions, sulfate ions, and carbonate ion. We already know that sodium would form with sulfate, sodium sulfate, sodium with carbonate will form sodium carbonate. So you can write your answer as sodium sulfate Na2SO4, sodium carbonate as Na2CO3. If you do not write the symbol, you would be awarded with full marks. Okay, I am writing those symbols just for your understanding. Part D is that the student tested different solution P and find it difficult to decide whether a solution contains chloride ions or bromide ions. The student also has a aqueous potassium chloride and aqueous potassium bromide. Suggest how the student could use the aqueous potassium chloride and aqueous potassium bromide to make it easier to decide whether P contains chloride ions or bromide ion. So before coming to the question, I am showing you the table which I was talking that it is given at the end of the paper. Last two sheets is containing of this paper. You can see from this table, when we have right answer for white precipitate, it is given SO4 minus 2. In one part, when the question was that white precipitate is observed, and we write because of sulfate ion the white precipitate is observed, and over here sulfate ion. Now chloride ions has a precipitate of white and bromide ion has a precipitate of green. Both these tests should be acidified with dilute nitric acid and aqueous silver nitrate should be added. So you're gonna use this table to give your answer. Add dilute nitric acid and silver nitrate to a solution. Now compare the color of the precipitate with the unknown. If it is white precipitate, it would be chloride ion, and if bromide ions are present, then the precipitate would be creamy. So this is the answer. You're gonna write that with the help of the table given at the back of this paper. Hopefully you get the idea how to read the table and how to apply in the question. This is a very important answer. You can take a screenshot of this answer. Moving to part E. Okay. The student add dilute hydrochloric acid. Okay, the student add dilute hydrochloric acid to another solution and a gas is produced. The gas is passed through the lime water. Describe how the gas can be passed through lime water. You may draw a label diagram to help the answer. So you need to use downward delivery method. Use a delivery tube from the reaction vessel. Bubbles the gas through the test reagent. Lime water is used, and it's like that. You're gonna draw the conical flask. Over here the glass tube. Over here is HCl you added, and lime water, and you put rubber flask, so lime water will turn to the milky. So this is the answer. You're gonna write and draw the diagram like that. Okay, moving to the last question of our paper, question number 4. Copper carbonate, that is CuCO3, reacts with dilute sulfuric acid, that is H2SO4, at the room temperature. The reaction is given. Copper carbonate and sulfuric acid would make CuSO4, copper sulfate, CO2, carbon dioxide, plus H2O, water. Plan an experiment to determine the volume of carbon dioxide formed when a known mass of copper carbonate completely reacts with dilute sulfuric acid. Your plan must include the use of the common laboratory operators, dilute sulfuric acid and copper carbonate. No other chemicals should be used. Your plan must include, this is very important, the operators needed, the method to use and measurement to take, and operators to ensure that the measurement are accurate as possible. You may draw a diagram to help answer the question. Okay, so first you're gonna write the operators. Operators in this experiment is used, or you can draw first a diagram, but I'm writing the operators first. Conical flask, boiling tube, gas syringe, burette, measuring cylinder are the few of operators. You can write any 4 from them, or you can write as many as you want. You can write 10 of the operators, and the diagram should be like that. Make a conical flask first, then put burette in, and from burette enter HCl, and at the conical flask also add copper carbonate, that is in the form of solid, and from the gas syringe collect the gas that is produced from this operators. Okay, now you can write your answer. First measure the mass of copper carbonate CuCO3 which you have added in the flask, then gradually add sulfuric acid, or you can add HCl in it. So you need to write H2SO4. Okay, over here in the diagram I have written HCl, I have changed into H2SO4. Then you need to add H2SO4 to the flask. Effervescence of CO2 gas will be observed. Keep pouring the acid until no copper carbonate left and the effervescence is stopped. Measure the volume of the gas produced repeat and take the average of volume, and also identifies the anomalies. So that's why you get the correct answer from this experiment. So you're gonna write that I'm repeating the procedure. First measure the mass of copper carbonate, then gradually add sulfuric acid to the flask. Effervescence of CO2 gas will be observed. Keep pouring the acid until no copper carbonate left and effervescence is stopped. Measure the volume of the gas produced. Repeat and take the average of volume. Identify anomalies through the experiment. So this was the last question of our paper. Hopefully you have the understanding of this paper. This was an easy paper, though some techniques like drawings are required and little bit of different from the previous P4 papers, but this shows that how the examiner gonna apply it into the next attempt as well. So if you get the idea of this paper, you should like the video and do share with your friends. Don't forget to like my channel and subscribe it. And also if you need to if you have any queries related to the paper, you can ask in the comment section. Inshallah, I will ask you or reply you in detail. Thank you so much for watching this video. Allah Hafiz.